Very tired.
Tired, right?
Yes.
Today,
Yeah, no. So hot makes you want to just have before tomorrow. 那我明天想要做这样雨崩一样。
你要坐那个地方吗？
啊？
你要坐那个地方吗？
没有，这里冷气吹到好一点。只是用这里这个插头是有电的啦。没有电了，没有电了。
不用紧，我用完电就关了。
春节那个应该还够5分钟。其实雨峰你太好了。没有，我前面这个没有电哦。Hey sir, has someone ever thought that you look like one of the Chinese education pioneer?
What?
Huh? You look. Has someone ever told you that you look a little bit like Lin Lian Yu?
Lin Lian Yu? Wow, I'm so proud. Yeah, isn't it? They really fight for. I mean, fought for the.
Yeah.
I mean, they really not fought. I mean, fought in the proper way for the Chinese education.
Yeah, and you kind of look like him, huh?
Are you sure? But I'm not that big. I look like him. Because of my hairstyle, right?
Face the shit lah. When you smile, looks like him.
I don't know. Every time I go to the barber shop, they always cannot fulfill my requirement. Always end up like this kind of places.
Maybe this hairstyle suits you the best, lah, sir. Look very professional, look very 斯文.
Like the old type of professor, very old, carry a lot of books. Want to read something, want to pick up the specs. Okay, class. Yes. Good afternoon. Okay, I know everyone is quite tired after a long day of study. Okay. Is it quite long day? Yeah, quite long. 8 hours at least. Okay. Now, before I can start the lecture, I want to check with you. Anyone still not able to find an assignment team? Anyone here still not able to find an assignment team? No, okay, class rep, please help me to take a look on this. Okay, so if you find that within your tutorial group you are not able to find assignment, those who are not able to find an assignment team, okay, please help me to help them, okay, to allocate the assignment team for them, okay. So and then the next thing is for your assignment, I guess you will start your assignment, and then for assignment for the part 2 is normally it's for the enhancement, right, isn't it? So you can exchange the program with your other assignment team to do the enhancement. So the marks will be based on how well the enhancement you have put, understand? Okay, how significant your enhancement you have applied to the existing system. So you may require to do a re-engineering somehow. Let's say for example, I guess that most of your code is Java, right, isn't it? Okay. okay? So maybe you can convert it into a web-based, and maybe you can convert it into mobile-based, it's up to you, okay? So I guess this way is better. Why? Because you have a significant change in your system, okay? At the end of the assignment, you need to provide a proper time, okay, for your presentation. But however, for the presentation, if you've asked Mr. Lim, I will prefer on face-to-face, but this one is depends on whether we got the time or not. You get me, okay? Because if you face-to-face, it definitely take a lot of time, okay? So maybe if really no time, maybe we can just either do it online or maybe we just have a video recording. Understand? Okay? But I want all the students to present on the because your what? Your presentation, the rubric got Q&A one, okay? So at least we can have online, okay? So if we are not able to do during the physical class, okay? So now, I would like to suggest that, okay, you can start your assignment part one already. You understand? Just to do some findings and write the report, okay, of I think it's 12 pages. If you have 4 or 5 students, then one student responsible to write 2 pages, then I guess within 2 days, okay, you can finish it already. You get me, okay? Why? Because I feel that the second part may take longer time. You may take longer time for that. So I hope that you can start your assignment as earlier as you can, okay? Now, for your mid-semester test, okay, we have changed to week 8, okay, Tuesday, this time, okay. So the coverage is from chapter 1 to chapter 5. There are 2 questions, each question 25 marks, okay. Each question may have sub-question, and total is 50 marks, but this 50 marks is going to convert to the weightage of your your midterm in the coursework. Your midterm is 40% of your coursework, okay, and your assignment is 60%. Therefore, I hope that you can do your assignment better, and somehow please try your best to score as much as possible in your midterm, because it did affect your marks one. Understand? So that's it, okay, for what I trying to tell you today. Now, for today, chapter 6, we are going to discuss about a new topic, which is the re-engineering. Okay, so are you ready? Okay, so am I ready? Ready. Okay. So now, yes. Any question? Hema? Where's Hema? Just now I just saw her sit with you, right? Where's Hema? Huh? Where now already? Oh, okay. So now, we need to start a new topic, but actually I'm not so used to this course now. Okay, so never mind. Okay, so class, for our software re-engineering topics today, okay, is regarding the concept of how are we going to re-engineer the system. So let's say, for example, we all know that from the previous chapter, our software sometimes need to evolve, okay, from time to time as according to the needs of the requirements, the change of the environment or technologies, okay, or maybe it's the need of to obtain become more useful, providing more features. However, in certain cases of example, a very old system, we call it a legacy system, where certain parts, okay, they cannot be changed anymore, or maybe it is how to say, they need to become a new system. For example, okay, Windows, your system is currently work at Windows Doctor 1, but however you want it to be a new system, okay, in which it can be hosted by a web hosting, okay. So in this case, original system may not be able to work as a whole in a web home profile because we want to design as a local operating system. Okay? So not the OS, I mean the systems that operate under a local platform. Okay? So in this case, then you may find that you want to buy a new system, maybe the system is not that work. Okay, maybe you just need to put certain part of the system to be hosted in the web hosting, for example. Okay, so somehow then in this case you may have to perform a re-engineering. What is mean by re-engineering? Re-engineering actually in general terms we say that okay is to study the existing system. Why do you study the existing system? Because we need to understand the existing system. Okay, and from what we understand, okay, we produce the abstract representation of the system. Maybe it's a diagram, okay. Maybe it's just a certain design, okay. Actually, it depends on what kind, which part of the system is going to be engineered. And then from that, you understand on the abstract representation, then you proceed on building the new system. Understand? Okay. So therefore, some people may say, okay, re-engineering actually is to build a new system from an existing or old system. Understand? And then something is why we need to do re-engineering. Let's say just now I mentioned about studying the existing system. Sometimes maybe the system documentation may not be complete or even don't have documentation. And we all know that okay, after the evolution of system from time to time, the system will become very complex already. Somehow it may not be really fully represented by the existing documentation. Example, your database, you keep on making changes on the database model, okay? So therefore, when you want to do it, okay, you try to revise back those data model, okay, which is really useful, okay? Sometimes we all know that when our system is being used for a long time already, definitely in our database there is a lot of what we call unwanted data one, okay? Those data may not be related one or maybe duplicate one, alright? Okay, so this time you may need to revise back the appropriate model for example. Okay, this is also part of the re-engineering. So for re-engineering, that is basically two major phases. Okay, two major phases, ASE, okay, two major phases. One of them is the reverse engineering. Another one is the forward engineering. What is meant by reverse engineering? When you Google search reverse engineering the word, okay, so most of the result given you is actually is to decompile the original compile code in back to the source code one. Okay, but however, when we talk about reverse engineering, actually it's not only limited to this one. Okay, it can be a process that we study the existing database. Okay, we come out with the representation of the data model. Okay, for the existing system, maybe the database is already too complex. Okay, and then maybe we convert the code, the compile code, exe or apt file back to the source code. That is a possibility. But provided you are not, in this case, provided you are not violating the laws. Understand? Okay? And somehow we may need to derive back the design of the existing system. You get me? Okay? Because the system is not already too complex, too messy already. Then you need to derive back the original, the design for the existing system so that you can proceed. Understand? This is reverse engineering. So reverse engineering in this case, okay, you notice that just now I said the example to rewind back the database, okay, model one from the database, actual database. So means that from lower level back to higher level, am I right? From the exe file, reverse back into the source code, a bit higher level, am I right? Okay. So from the existing system source code, maybe or the database, we can get back the design. So lower level back to higher level. Understand? So therefore, we call it as a reverse engineering. Normally, when we develop software, right? Okay, we start from high level, then go back to until the tooling, right? Isn't it? Lower level. But reverse engineering is the other way around. From lower level, we write back the higher representation of the system. Maybe it's a design, maybe it's a source code, recover back from the source code to the source code, or maybe you can derive the higher representation, maybe it's a conceptual model of the existing system. Understand? Okay? Then from the conceptual model, sometimes, okay, we can decide, okay, what is the usage of conceptual model of the system? Is there any student from Ryan here? No. Okay. So. Okay. Yes.
怎么叫做弧线？我也不知道。L。
Anyone know why we need to have a conceptual model? We know that conceptual model is very high level one. Okay, even does not come to the high level design yet. Okay, maybe it's still in your SRS, not SS, software analysis or software requirement engineering phase. Okay, so why we need a conceptual model? Comment? Anyone? Asan? Have an overview. Okay. Maybe from the conceptual, we also can discuss the purpose, the objective, or the goal of the system. Am I right? Okay. So when you have the existing system, because they say that re-engineering is to build a new system from the existing one, right? Somehow we may need to revise back, okay? Is it the new system should have the same objective goal with the old one? You understand that? Okay? So if got changes, then the representation may need to be a bit modified to get the understand. So now we know that reverse engineering is to derive something which is high level from the low level. Okay. So therefore, there is a concept, okay, or principle that describes this one, which is called the principle of abstraction. Okay. We know abstract means less detail, right? So this principle of abstraction means that the representation, the representation of the existing the representation information now, okay, will be reduced. Reduced means that it becomes abstract, less informed, understand? Okay, when we perform we become reduced, okay, okay, so this is the abstraction. Then from what we have the model that we derive from the reverse engineering, we start to create a new system. Okay, we may need to modify. Okay, we may need to create, design, okay, and so on and so on. Okay, so therefore, from the forward engineering, okay, we start from the high level to the lower level. So the principle applied here is the principle of refinement. Refinement, R-E-F-I-N-E-M-E-N-T, okay, refinement. So it's the opposite of the principle of abstraction. It means that the level of the detail of the information now, okay, will become less abstract. Less abstract means more detail, understand? Okay, so this is the principle of refinement. Okay, so then this is until you derive the new system, come out already. So this entire process is called it's called re-engineering. Understand? Okay, so okay, that's it. Bye-bye. See you. Okay. I already summarized for you already for this chapter.
Yeah, bye-bye.
Okay. Now,
See you next week, sir.
okay. Now we look at the slide. Okay. What is re-engineering? This one is the definition. Okay. It's an examination, analysis, and restructuring of existing software to reconstitute it into a new form and the subsequent implementation of the new form. So just now I say, okay, to study the existing system. Okay, study means that we examine, we analyze, right, isn't it? Okay, from the restructuring, from engineering, we need to do some modification from the existing system to create a new system. Understand? Okay. So for the goals, okay, why we need to do re-engineering? First is to understand the existing system, okay, and to improve the quality and functionality of the system. So this is the goal of re-engineering. Okay. Now, what are the risks? There is some risk in the transformation because we are going to transform from the existing one to the new one. So what is the possible risk? What are the new one may not have the same function with the old one. Okay? And then the new one may have more worse than the old one. Means that the quality is worse than the old one. Why? Because maybe the way you do it is not correct. Understand? Okay? The benefits are not realized. Yeah, maybe you will feel that, okay, I convert this system, okay, to a website from the legacy to a website system. Okay, so it can do this, do that. But however, once you've done already, you realize that actually the benefit, okay, that brought by this new system may not be that so significant one. Understand? Okay, this will happen. This will happen, yeah. So, software systems are re-engineered to keep by keeping one or more of the following general objectives. When you do the re-engineering, make sure that, okay, you improve the maintainability, migrating to a new technology, okay, improve the quality, prepare for functional enhancement. Understand? So these are the 4 general objectives for software re-engineering. These 2 principles, this is just now what I said. Principle of abstraction. Okay? Now, this is the principle, is from the definition. I have to read out. The level of abstraction of the representation of the system can be gradually increased by successfully replacing the detail with the abstract information. Means that the level of abstraction means that the level of simplification of the system representation can be gradually increase. Increase means that become less involved. Understand? By replacing those info with more abstract info. Okay, so this is the principle of abstraction. Principle of refinement, the other way around. Okay, the level of abstraction of the representations of the system will be decreased. Understand? Okay, by replacing those abstract information with more detailed information. Understand? Don't be confused by the word less abstract. Less abstract means less simple. The other meaning is more detailed. Understand? Okay? Look at this diagram here. It's a common diagram to show the application of abstraction and refinement principle. Let's say, for example, from implementation to conceptual model. Okay? Definitely more detail, a bit less detail, a bit less detail, and then very less detail, right? Isn't it? So the abstraction level is increased. From the conceptual to implementation, the abstraction level will be decreased, right? Okay? So means become more details. From conceptual, very simple, maybe just a very simple diagram, and then come to a high level design requirement by level, become more details already. So this shows that the application of refinement principle. Understand? And the other way, on the other, in addition, we also can see that this is a reverse engineering. Okay? This is a forward engineering, right? The review system.
Hello.
Who is singing?
Yes, now I have got class, so can call me later.
So,
Okay.
you can see that
Okay.
from what we have practiced our development, high level to low level, right? So, this is reverse engineering, this is forward engineering. And reverse engineering, we apply the rules of the principle of abstraction. For forward engineering, we apply the principle of refinement. Okay? Now, look at this one. This explains just now the diagram lah. Conceptual level, okay? The software is described in terms of very high level concept and the reason why we need this software. Means what is the objective, what is the purpose, right? Okay? So, address Y aspect in the conceptual level. Requirement level, what the function should, the system should perform. Am I right? Okay? So it's asking about what. So what the system do. And then for the design level, what and how the system should perform. Am I right? Okay? What is the structure of the system? How the system should integrate to perform the task. How is the process should be performed. So what and how. Implementation, okay, is how the system is being deployed, allocated, and implement. Understand? So this is the implementation. So therefore, from the conceptual is why. Requirement, okay, or analysis is what. Design, what and how. For this one, implementation is how also. Understand? Ask the question of how. Now, refinement process from high level to low level. Why, what and how. Understand? Okay? Concept, this is the conceptual. Requirement, design, implementation. For abstraction, how, implementation, design, requirement, conceptual. You see that? So this is the abstraction process. It also can refer as the reverse engineering. Okay? Refinement process, forward engineering. Okay? So this is what is represented by this diagram. We come to another principle. It's called the principle of alteration. This principle of alteration means that they make changes to the system. Okay? But however, it does not involve any changes on the degree of abstraction. It does not affect the level that the how many information should be presented in that particular stage. Understand? Okay. It does not affect the abstraction level of the system representation. So this is called alteration. It does not involve modification, deletion, and addition of information. It does not change the information, okay, of the system representation. Okay? General model for software re-engineering. Existing system, reverse, forward. You get me at task. Reverse, forward. And then implementation. What is mean by this one? This is the changes, not the activity. Because this one quite confusing one. Because later you see another 4. Okay, then you very difficult to differentiate. So, okay, like this lah. We call this one is type of changes on the system characteristic. Understand? Okay? Changes on the system characteristic. Bear in mind. Okay or not? Okay? This is very, very important one. Okay? Changes on the system characteristic. Okay? So, rethink. From the existing conceptual model, we need to rethink back whether the new system existing goals, objective should be still remain or we should have changed or not. Understand? If you change that, we rethink a change on the goals of the objective of the system. Am I right? The characteristic. So we specify on the requirements, sometimes may need redesign. Yeah. Okay. We put on, okay, this is alteration. All this alteration will affect the characteristic of the system. Understand? So these are the changes. Understand? Made to affect the characteristic of the system. You get me? Okay? So it also can refer to the changes of system characteristic. Okay? So reverse engineering, forward engineering. Okay? Another model, horseshoe model. Okay, so maybe I can use another. There is another diagram here to show the horseshoe model one. This one. Then I do this one first. Okay. So this horseshoe model, okay, is by this man Tom. Okay, and he showed that okay, it's like a horseshoe. You see that? So from the legacy software, then we understand, abstract, and produce the abstract representation. Then go to high-level architecture, analyze it, improve, restructure, modify, okay, alter, and so on. Then improve and restructure model. This is the new model of your system. Okay, and then go to generate and refine. So this is the horseshoe model. Actually, it's similar to just now our rectangle. Okay, just a different diagram, but however, it shows that okay, this is the process or the cycle of re-engineering. Understand? Okay, by using like a horseshoe one. But however, there is some arguments saying that okay, you can see that the direction is like a U-turn. Am I right? It's following this horseshoe form direction. But some argument they say that actually not necessary to follow like this line. You can have from here, let's say the coding, okay? I can just change the coding to become the new one also can. From the design part, okay, I can change to the design part, and you get me a task. Because when we say re-engineering software, we're not necessary to re-engineering the entire software, maybe part of the software. You get me a task, okay? So that is the argument there. So what is the argument here? Before we talk about the argument, okay, so we look at this explanation on the horseshoe model, okay. So divided into 3 stages, okay. This is from the horseshoe model. You can see that 3 stages: understand, abstract, okay, and then improve, and then generate and refine, okay. So first, reverse engineering may be required if a software system technology, okay, and followed by a software reorganization, and followed by the new system restructure. Understand that? Re-engineering, reverse engineering, design, restructuring, okay, restructuring, design, and then followed by the refinement, design. Okay, so this is what I'm talking about on the next slide. Okay, understand? Anyone don't understand? Anyone don't understand? Please. Can
我回去看，我回去看你口令，刚没有听到。
Okay. So, any question before I continue? Repeat. For this horseshoe model, he shows the re-engineering process. Okay, in this social model, it said that this process they are separate into 3 stages. One is the reverse engineering, in which understand, extract, and abstract, okay, to create the abstract representation of the system. Reverse engineering, 1 stage. The second stage, restructure. Okay, restructure, improve, and something modification done. Okay, second stage. And then third stage is further refinement to generate the new system. It's called the forward engineering. 3 stages. However, this is on the second slide according to the horseshoe model. Any question? Jason? How about this side? Vinisha? Now I can correctly pronounce your name already. Yeah, Vinisha, any question? No. Then Loving? Any question? Loving friends? How about our friend at the back? No, okay. So then, but that is just now I said, okay, this horseshoe model that said, okay, follow this way. Am I right? From lower level, okay, design analysis come to here, and then make adjustment, proceed to the refinement. But however, some may say, okay, actually they argue that, okay, in the horseshoe model, actually not necessary to follow like this, a horseshoe shape. They can say maybe from the implementation, let's say for example the source code, okay, they can from the source code they can directly modify one, am I right? And then design analysis also can directly modify so that they can from here to here to become the new implementation. No need to wait for the new model, understand, to derive or refine to the new system. This is the argument. You see that this is a horseshoe model, okay, assessment. A more detail of horseshoe model. You can see that source code, code structure, functional level, architecture level, base architecture. Okay, transformation, restructure, whatever, come to here. Okay, but however, some argue that okay, I can just from here to here, possible. Okay. From here to here, possible also, am I right? Okay, so they argue, okay, not necessary to be like this, understand? Okay, so, okay, that's it for the horseshoe model. Now, therefore, from what we understand, this is the formula of re-engineering. Reverse engineering plus the changes plus the forward engineering. Okay, this is the formula. Okay. Remember this one, changes on characteristic of system is referring to this one. Changes on characteristic of the system. Okay. Everybody see that? Recode is definitely in the code level Okay, so you alter the coding. Okay, maybe you rephrasing the code. Okay, and then you change the program translation. Okay, to make changes at the code level. Redesign definitely we restructure the software structure or architecture. Okay. Modify the data model, means your database model of your system, replacing those algorithms with a better one, and so on. Okay, so this is redesign. And the next one, re-specify, change the requirement. Okay, change the requirement and change the scope also. Rethink, reconsider the objective goals of the system. Okay, so this is the thing. Okay, we think again why this new system we should have. Understand? strategy. That's why I say it's quite confusing one. Okay. So that one is the changes of characteristic. Understand? This one is the strategy. Be careful. Okay. So we start with the rewrite. Can or maybe we take 10 minutes break. Okay. I cannot already. Okay. So we take 10 minutes break. Okay. Let me get back my energy first. Okay. So where's Emma? Is it the bag is hers one or yours one? Oh, yours one. Then Emma just now here, then she went back. She said she went back. Or is it anyway that someone can go and did she say anything? Oh, okay.
privacy. mobile application 写的对了，
哪一种？
忘记了，在那个还有另外那个，打给我，那 offer sales and marketing。哎呀，这么写。打到不好意思，瞬间就上了，
这不玩，
怎么了？
这是玩，
Okay, class, shall we continue? Just a few slides, then we can end already. I still think that I have something for you.
进展的话，错了，就底下能看到的，
你再可以改的文件。
有时间的。
让打过来，让打来了。我 apply mobile application developer，然后我要不要做 sales marketing？
哎，我不要玩了，不要玩。
Yes, I found it.
Okay, so I guess we can sit up and continue. Okay, just a few slides. Where's the slide? We still have 10 slides. Okay. So class, we look at the strategy. Just now I say this one is important because okay, you need to know that why. Please do not confuse with the change of characteristic and the strategy, because it's all rewrite, rework, replace, and then this one is re-specify, rethink, recode, and redesign. It's different thing, understand? Okay. So this is the strategy. Now rewrite strategy actually is to alter the code. Okay, to alter the system coding. Okay, let's say for example, we rewrite the code from Java. Okay, by using let's say Kotlin. Okay, by using C#. Okay, but these changes will not change the system representation. Understand? It will change the system representation. So the next one, strategy, rework. Actually, we do all the things. Apply all the principle, abstraction, refinement, and alteration principle. Means that we do everything. Okay, perform the reverse engineering, study the system, come out with the until a certain level, come up with the abstract representation of the existing system, make necessary changes, alteration, restructuring, and so on, and then refine to come up with a new system. So this is the rework. Understand? This is the rework. Replace okay, replace only apply two principle in which is the abstraction and refinement. It does not, okay, how to say, apply the principle of alteration. Means that, okay, they try to replace, means that they try to replace certain part of the old system or the old system with another one. Understand? Okay, with another one. So this is a replace. Re-engineering process variation. This one is referring to for your homework, but however, no need lah. Okay, because answer is given here. So this one showing the variation means that, okay, in certain level, okay, some strategy apply, certain changes may not be suggested. Let's say for example, look at this table here. For implementation level, okay, the type of changes is recode, redesign, specify. Actually, it's all the same reason. Okay, they just list down the things. So re-engineer strategy, rewrite, rework, and replace. So for implementation, recode, okay, changes. We try to apply the strategy of rewrite. Yes, it's suggested because it's the coding level, ma. Okay. For rework, yes. Replace the code, also yes. However, for redesign, you can see that the changes you want to apply in the implementation level, redesign, you want to rewrite, no. Okay, rework, yes. Replace, yes. Why? Because redesign actually is for the back one. Look at here. Okay, for the back one, actually, a target system can be created, but the likelihood of achieving good results is low. Why? Because in the implementation level, why you want to how to say, redesign things, okay, by adjusting the design, okay, into different representation. However, you rework is different. You rework the design, okay, for the coding, okay, you design the coding, no, okay. So for the re-specified, definitely no, because how are you going to re-specify the requirement? It's already in the implementation level already. Okay. So now look at this one, requirement. Recode or is no. It's in the requirement level. Okay, why you want to perform the recode? Redesign, no. Re-specify, yes. Rethink, you try to rewrite the what? You try to rewrite the objective or goals, actually is not suggested. Why? Because it will affect because this one is at the higher level of this requirement, right? Conceptual level is high level than the requirement. So if you want to perform the rethink, I guess, okay, it's not a good idea for the rethink by using the rewrite strategy. So this one, yes, rework because you do everything, yes also. But however, that is a dash next one, okay. You can see that in this explanation here. Same as yes, but starting degree of abstraction is lower than the upper degree of abstraction within the conceptual level. Is okay, but this is the dash one is okay, but however, actually this requirement level is lower than the conceptual level. So, but you start the rethink here. It's acceptable for rework and replace. However, rewrite objective, no. So this is how this table. Any question? Any question?
I don't understand the table at all.
Difficult to understand. Yeah. You can see that.
It looks like it's simplifying something, but it makes something more complex.
It's not simplify something. It's just that they found from their study, okay, they found that, let's say for example, for the let's say conceptual level, for example, conceptual level is the highest level, right? So these are the changes: recode, redesign, re-specify, rethink. So from the conceptual level, okay, are we going to do the re-engineering changes on recoding the system, change the code, change the design, change the requirement? No, it's not suggested. Why? Because before you know the goals are, okay, how are you going to change the requirement? Am I right? Okay, so therefore you can see, oh no here, regardless of what kind of strategy you are using. Okay, however, for this one, we think you try to rewrite the objective or goals, yes. You try to rework everything for the conceptual model, yes. Also, yes, it's okay, same as this one. This dash is same as this one, so it's possible. Okay, it's possible. Okay, and however, for this requirement level, you want to rethink back the goals okay, by rewriting apply the rewrite strategy, okay, so it's not suggested. Understand? Because this one is lower level than this one. Okay, you are doing in a different way already. So for rework and replace for the what we call rethink, yes, it's possible. Okay, but however, you are not performing in the conceptual level, but you are performing in the requirement level. Understand? Okay, this is just a difference only. Okay, and for the what? For the redesign, okay, design level okay, you try to re-specify the requirement by using the rewrite strategy. Okay, actually it's not suggested because this redesign is lower level than the specification level. Okay, and however, if you want to rework for the rework strategy and the replace, yes, because you rework, you try to redo everything, so it's possible. Understand? So this is what this table means. Understand, class? Right? So therefore, I say that just now the changes is very important because it's very easy to get confused one. Understand? For the strategy with the strangers. Okay? Now continue. Approaches. Okay, approaches. Now in this chapter, you need to be very careful with the word approaches, changes, and strategy. Understand? Okay, very easy to get confused one. Okay, now approaches. Okay, re-engineer approach. Okay, so it's based on the two aspects. Which one is the extent of the engineering to be performed and the rate of substitution of the system with the new one. Okay, same means that how extend the engineering task should be until and the rate of substitution, the replacement of the replacement rate okay, of the existing system with the new one. One is Big Bang. I don't know why so many people want to use this word Big Bang. Okay, so maybe what is Big Bang? Big Bang is a very famous Korean artist, right? Isn't it? Okay, so and then there is a series called Big Bang Theories. Am I right? Okay, so many years ago. Okay, so now what is a Big Bang approach? You're going to see this Big Bang again, okay, but for different thing one. Okay, this Big Bang approach is the re-engineering. However, another Big Bang approach is for the migration system in chapter 8. Okay, so hope that you won't confuse. So therefore, now you understand that for your testing also got Big Bang one, am I right? Am I right? Okay, software testing. One of the approach is Big Bang, am I right? Is it? Okay, so no, integration of Big Bang is it called? Okay, so Big Bang approach, when we look at the word Big Bang means that everything at once. Okay, we replace the entire system at the same time. Okay, so once the project is started, okay, it continue until everything is complete. Understand? Okay, we do the entire system at once. Okay. So if part by part re-engineering isn't this method is applied to those systems where we cannot re-engineer part by part. Understand? We cannot start with this part, okay? We must have re-engineer the entire system at once. So therefore, we use the Big Bang. Okay, but however, it's quite risky also. Why? Because when you do, okay, you have put in the resources, everything, but however, when the outcome come out, okay, it may not be what you expected. Understand? So it's quite risky also. But unless that this system, you are very well versed, and then maybe the size of the system is not that huge, okay, then maybe you can consider that. And somehow, some system may not be able to be decomposed, means that to be decomposed for re-engineering, okay, from one part to another part, then you have to use this Big Bang, okay? Now, continue. The next one is incremental approach. So this incremental approach, okay, re-engineering means that we re-engineer the system, okay, but part by part gradually. Maybe we start with this part first, or maybe we start with these two parts, maybe in parallel also boleh, understand, okay? So we start this part first, after that we continue increase with another part, we continue increase with another part, understand? Means that the re-engineer part, the portion is keep on growing, okay? So this is the incremental approach. The benefit is, okay, the benefit is, okay, so those re-engineer the new part now, okay, are able to be identified easily, okay, and then if there is an error or problem, you are able to detect earlier and easily, understand? Okay, because part by part now. So, but however, okay, you need to keep track of those interim version of the part that you have done now, understand? Okay, so in compared to Big Bang, this is less risky. However, the disadvantage, as I said, you need to keep track of the different versions, interim versions that you have produced during the re-engineering, understand? Okay, and this one may take time. Okay, may take time. Okay, so however, by using this approach, the entire architecture may not be able to change, understand? Because you part by part, right? Okay, so may not be able to change the entire system architecture at once. Now, partial, this approach is a bit different. Means that you just re-engineering certain part of the system, okay? Then you connect back this part into the existing system. So this is called partial approach. So as the notes here, there are 3 steps, okay? So first step is you try to identify, okay, which part is going to be re-engineered and which part is not going to be re-engineered, okay? Then for the second step, you start re-engineer those parts which is required re-engineering one by either using Big Bang and incremental, okay? So, and then after that, okay, so those who are not going to be re-engineered, okay, then you combine with the new one, okay, the new one, okay, with those which is not need to be re-engineered. So this is called the partial approach, okay? Okay. Then the third one, so many. The third one, iterative approach, okay? So means that you try to carry out, this is more on the source code wise, okay? So you try to re-engineer the source code, okay? Re-engineer the source code with different module, functions or procedure, okay? At the same time means parallelly, okay? And then repeat this one until all the things is being re-engineered. So this is iterative approach. The next one, evolutionary approach, is almost same with the incremental approach. Incremental approach means that you build one and then you continue with another one on the top and so on and combine. This one is different. This one you build one, okay, then you replace the old part with the new one, and then you proceed with and build another new one, and then after that you replace this part with the old one, replace the old part with this new one. So this is called the evolutionary approach. Okay, any question or class? Any questions? Any questions? No questions now, okay. So therefore, as your homework, before we come to this topic, source code re-engineering reference model, score IM, okay. So I hope that you can go back and have a read on this one first. Okay? Have a read on the score IM model first. Because this score IM model nearly got a lot of phases. You can see that 11, is it 11? 8 or 11? 8, yeah. 8 phases. So please have a read on this one first. Then next week we are going to continue. Okay? Any question before we proceed? Any question, class? Okay, I'm going to skip this one first because this one really takes a lot of time. Okay, hopefully you can understand. And we code reverse engineering, same thing. Okay, we skip this one, we jump to here. Code reverse engineering. So what I mean by code reverse engineering, okay? So it's to define the component of the operational software, is to define the interaction between those components and to represent the system at a high level degree of abstraction or in another form. Okay, so actually this is to get the information of the existing system from the codes. Okay, get the information of the existing system from the codes so that we can produce an abstract model. Code reverse engineering. Okay, so what are the factors that are necessitating the need for reverse engineering? The programmer has left the organization. The language is obsolete already. Insufficient documentation. Business are totally relying on the software. Okay. The company acquired the software system as a part of the larger acquisition and lack access to all the source code. The system requires adaptation or enhancement, but the software does not operate as expected. So these are the factors that lead to the needs of code reverse engineering. But however, I can also say that these are the factors also the factors that cause the needs of reverse engineering. Not necessarily should be the code reverse engineering. Understand? So reverse engineering techniques. These are the techniques. Okay. Lexical analysis, syntactic analysis, control flow analysis, data flow analysis, program slicing, visualization, and program metrics. These are the metrics that we may apply in the code reverse engineering. What is lexical analysis? Okay, means that for our source code, we try to separate or break down the source code into a unit of lexical unit. Understand? Okay, so means that let's say int, integer, okay, x, or string x. We try to break this one. Let's say this is a string, this is integer, okay, by using the compiler, okay, so that we know that okay, which one is represent a variable, which one is represent a keyword or a command or a data type. Understand? Okay, we break down, okay, then we are required a lexical analyzer, okay, that perform this task, which is in the compiler. Actually, this is the task also. This is the task of the compiler also, okay. And syntactic analysis, actually, this one is to perform an analysis, okay, on the syntax of the programming language. If you have the source code, we need a parser to perform this syntactic analysis, okay, so that okay, he will come up with a certain form. We can identify the syntax of the language to see that whether this syntax is represent what okay, is it the syntax correct or not okay, so this is the syntactic analysis. Okay, in this case, we may need to use a certain form called the vectors no form, okay, used to describe the language grammar. Understand? Okay, so this is the syntactic analysis. Actually, all is performed by the compiler or the translator or the interpreter. This is an example of BNF form. Okay, just for your information only. Okay, this is the example of BNF form. You see that? VAR, procedure, core, okay. So syntax and syntactic analysis. Okay. So now, control flow analysis is to check on the flow of the system process, the control wise. Okay. So means that from this procedure to what procedure, from this statement, okay, is you're going to control the flow to which statement. So control flow analysis. So this analysis will perform into two different ways. One is to check the control within the procedure, within the functions, or some will check the control flow between the procedure or functions. Okay, so this is the control flow analysis. Intra-procedure analysis of this one is to check on the flow within a module, a program, or function. Inter-procedure analysis is between the what we call between the module, functions, or program. Understand? Okay. So for the intra, we may use CFG. For the inter, we may use call graph to do it. Data flow analysis, this one is to check or analyze on the flow of data. Means that the data pass to a variable, okay, and this variable will happen or will be used in module, which statement, and so on, okay, to analyze the flow of the data. Program slicing, this one is a technique that we try to separate the statement of a program, okay, according to certain criteria. Okay, why we need to slice it? Because we need to extract those related statements, okay, that based on a certain criteria, we extract related statement from a program, okay. So this extracted statements is called program slice. Understand? Okay. So for our analysis to check maybe on the dependency of data or dependency on the flow. Understand? So this is a program slicing. Program slicing can be backward and forward. Forward means from the start from the beginning, okay, then we on certain criteria we check down, okay, which statement is affected. Backward, from maybe from a certain criteria in the certain statement of a program, we check backward, check back, okay, check up, okay, and then see which statement, okay, is affected the changes of value of this particular statement. So this is the forward and backward. Understand? Don't worry. This one practical we are going to do. Okay. So and that's it. Any questions, class? Any questions? And remember, as a reminder, please go back and have a look on the score RM by the reference model, okay? So source code, reverse engineering reference model, okay? So because this model got 8 stages, I'm not so sure whether I can finish these 8 stages within the half an hour. So we are going to discuss this one next week, okay? So before that, please go and have a read on that. If you feel that there's not so more information, you can go and Google it. Understand? Okay, any question? Any question? No question? Okay, no question. Then I have another thing to ask you. Our midterm is on week 8, right? Okay. Do you think that you need a mock test before meeting? Do you think that you need a mock test before meeting?
Will not count
Don't
marks
be
Won't count marks
listen, that is not a tips. Okay, just a mock test for you to switch to the situation of the test only.
Okay, sir, we understand, sir, we understand.
No, I say you say only. Okay.
We understand, sir, we understand one.
How? Maybe we do a mock test for the not so many chapter lah. Okay, maybe for chapter 1 and chapter 2 lah. Okay, so include chapter 1, 2, or maybe 3, 4, 5. Then this one, okay, is on the actual test lah until 5. How? Yes, others group, senior group, year 3 SEM 2. Yes, group. How is it? Do you like a mock test for the midterm? Senior group. Senior group.
要讲
Who is the senior group? This side, this side, and at the back, yeah. So,
麻烦
senior group how?
这样是什么
Huh? Okay, okay, so the mock test will cover chapter 1 and chapter 1 is what? Sorry. Okay, we cover chapter 1 and chapter 1 to 3 lah. Okay, so but your actual midterm is cover from chapter 1 to 5. Okay, so I guess because not to interrupt with the exam with the lecture schedule, okay. So maybe we can have less question. Let's say 1 question is okay, rather than 2 questions. 1 question okay, 1 question.
25 mark lah.
25 mark like that lah.
Oh.
Okay. Yep.
The actual midterm will have 2 questions.
Midterm have 2 questions. Okay. So I guess it's better lah because since my retinal scan is failed already, so better to have a mock test lah. Okay. So okay, class. Senior group, okay Okay Then junior, yes. Who is raising? Someone is raising the hand. Okay okay. So that's it lah.
So next week
Hey, please don't misunderstand. This one is not the tips for the test. Understand? Okay, just for you to familiar with the format only. Okay, so doesn't mean that this question can come out then you can't come out then GG already. Understand?
Nobody
Okay,
we understand one.
Okay, pass. Okay, okay. So then when we are going to have it? Week 7 no? Week 7 Okay, that's it lah. Okay, any question, class? Any question? Oh, I see everyone is eagerly going back already. So hot Okay, any question? Remember to sign attendance. Remember to sign attendance. Everyone, please sign attendance. Sign attendance. Okay. So that's it lah. You can dismiss already. Okay, thank you. See you.
Sir, you're not my supervisor, but you want to try my FIP a little bit.
No.
So sad lah.
这个好看。
这个什么好看？这不是整个 image 放上去，他们看不了，又不是我拍的。我唯一好看的
是你那个 opacity 要加深一点。
哪一个？
这个 load in 啊，
这个
加深一点，不然看不到。
再加深就低。
后面太强了。除非你把我后面的 opacity 加变低了。
啊，你就看到后面那个绿色的。
加那个 robot 的，你加得到那 robot？
来到 floor 啊？
没有那 robot， 你要去 verify 你是 robot。
有啊，可以加到啊。你要我 set difficulty set 很难也可以，可是我现在礼拜我就全部 set 容易了。